Welcome back to our Chem 151 video series. In this video, we'll do some practice writing and balancing equations. Our first description says if aqueous sodium bicarbonate decomposes into sodium carbonate, carbon dioxide, and water, write a balanced equation for the process. What we need to do first is come up with correct formulas for each of these compounds: the sodium bicarbonate, the sodium carbonate, carbon dioxide, and water. Also, the words decomposes into will separate the reactants and products. Anything that comes before is a reactant. Anything that comes after is a product. We'll begin on the left side of the equation with sodium bicarbonate. Sodium is on the periodic table in group 1A. Any element in group 1A, when it is a member of a compound, will have a charge of +1. Therefore, we write the symbol for sodium Na, and we write the charge +1. If you see a plus symbol without a number, it's automatically +1. Bicarbonate is not on the periodic table, but instead it's a polyatomic ion. If you don't remember what this is just yet, it's always best to go to a polyatomic ion table to make sure. On this polyatomic ion table, bicarbonate is near the bottom, and its formula is HCO3 negative. When we combine the Na plus with HCO3 negative, we can see that their charges are both equal but opposite. Therefore, we can combine them together and make the compound NaHCO3. This takes care of our only reactant. Now we'll draw the yield symbol and deal with the other compounds. Sodium carbonate will be fairly similar to sodium bicarbonate. Sodium is still a charge of +1. Carbonate is also on our polyatomic ion table. We can see carbonate is near the top, and its symbol is CO3 2 negative. In this case, the charges are not quite equal. Our positive is only +1, while our negative is stronger at -2. Therefore, we have to add 2 pieces of sodium to neutralize the carbonate. If we have 2 pieces of sodium, that would give us a total charge of +2. Therefore, our correct compound is Na2CO3. Now, let's have a look at carbon dioxide. We'll begin by writing carbon, and then dioxide means we have 2 pieces of oxygen. Therefore, our compound will be CO2, remembering to put the 2 after the oxygen to show that there are 2 oxygen. Our next compound will be CO2, and we'll write that with a plus between it and Na2CO3. Our final compound on the product side is water, which we know is H2O. So now we know what our reactants and products are. Now that we have the equation, we'll need to balance it. Let's begin by writing each of the atoms that are present in this equation: sodium, hydrogen, carbon, and oxygen. Let's go to the left and count each of the atoms. In the compound on the left, we have 1 sodium, 1 hydrogen, 1 carbon, 3 oxygens. On the right, our sodium is in this first compound, Na2CO3, meaning we have 2 Nas. The hydrogen is in the last compound, that's water, meaning there are 2 of them. Carbon is present in 2 of the compounds, 1 in the first compound, 1 in the second compound. We'll write 1 + 1 for that, for a total of 2. Oxygen is present in all 3 compounds. We have 3 from the first compound, 2 from the second compound, and 1 from the final compound. Added together, that makes 6. So that means we don't have enough of sodium, hydrogen, carbon, or oxygen on the left. You can see we clearly have less sodium, hydrogen, carbon, and oxygen on the left than we do on the right. So we have to think, what can we multiply everything by to make the atoms balance? If you look to sodium first, you can see that since you have one sodium on the left, if you doubled that sodium, 1 times 2 would make 2, and then the sodiums would be in balance. For the hydrogen, we can do the same thing. Times 2 to the 1 hydrogen we have on the left would give us 2 atoms of hydrogen. You may be able to see we can do the same thing to carbon. 1 times 2 would give us 2 carbon, which would equal the 2 carbon on the right. And then if we did the same thing to oxygen and took double the oxygen, 3 times 2 would give us 6. This is equal to the 6 that's on the right. So all we need to do is multiply everything times 2. The way we do that is by placing a 2 in front of the NaHCO3, showing that we are going to double the sodium bicarbonate, which doubles all of the atoms that are in sodium bicarbonate, which makes the left side equal to the right side. This means this equation is now balanced. Our balanced form of the equation is 2 sodium bicarbonates, 1 piece of sodium carbonate, 1 carbon dioxide, and 1 water. We'll do another example. If barium nitrate decomposes into solid barium, nitrogen gas, and oxygen gas, we'll write a balanced equation for that. Let's begin with barium nitrate. Barium is group 2 on the periodic table. Elements that are part of compounds that come from group 2A have a charge of positive 2. This means we'll write Ba for barium and then 2 positive to show that it's positive 2. Nitrate is not on the periodic table, but it is polyatomic. Once again, we look to our polyatomic ion table. Nitrate is located in the second column, and its formula is NO3 negative. We can think of negative as 1 negative, so we'll write NO3 1 negative. The charge for the barium is 2 positive, and the charge for the nitrate is 1 negative. That means that if we put these together, they will not make a neutral compound. We'll need to use 2 pieces of nitrate. If we use 2 pieces of nitrate, our new formula is BaNO3. We'll put the NO3 in parentheses, and we'll put a 2 afterward to show that there will be 2 pieces of nitrate. Now the description says that this barium nitrate will decompose. This means that the barium nitrate is our reactant, and all items to the right of that in the description are products. Therefore, we'll write a yield sign in between. Our first product is solid barium. If you're ever given that you have solid metal, that metal will automatically have no charge. That's different from the barium ions that were part of the barium nitrate compound. Solid metals are no charge, but metals that are part of a compound will have a charge. Therefore, when we write solid barium, we write Ba, but we do not write a charge above it. We'll put a plus after it and go on to our next compound. That's nitrogen gas. Anytime you have nitrogen with the word gas after it, that means that nitrogen is diatomic. And diatomic means you'll have 2 atoms in nitrogen gas. Therefore, when we see the words nitrogen gas, we don't write in, instead we write into, because this is how nitrogen exists in nature. The same thing applies to oxygen. Oxygen is another one of our diatomic gases, meaning that we'll write O2 rather than just O. So now we know what our reactants and products are. Now we'll balance each of the atoms. We'll have barium nitrogen, and oxygen. On the left, we have one barium. On the right, we also have one barium. For nitrogen, we have an N inside the parentheses, but a 2 on the outside. The nitrogen inside counts as 1, but since we've placed a 2 on the outside, we'll multiply that 1 by 2, giving us 2 nitrogen. On the right side, you can see we already have N2, therefore the nitrogens are in balance. For oxygen, we have a 3 inside the parentheses on the left. But there are 2 pieces of nitrate. Therefore, we multiply that 3 times 2, giving us a total of 6. However, on the right side, we have only 2 oxygen. Therefore, the barium and nitrogen are both in balance because the left and the right side for barium are both 1. The left and the right side for nitrogen are both 2, but the oxygen is at 6 on the left, 2 on the right. So what can we multiply the 2 by to make 6? We could multiply that oxygen by 3, because if we take 2 times 3, that will give us 6, which will balance our oxygen. Therefore, we place a 3 in front of the O2. With the 3 in front of the O2, we now have 3 times 2 oxygen. 3 times 2 makes the 6, which is a match for the oxygen we had on the left side. Therefore, the balanced form of this equation is BaNO32 yields Ba plus N2 plus 3O2. Thank you for watching, and we'll see you again soon.